Suppose we are given five sets: the universal set, the set A, the set B, the set C, and the set D. And we asked to compute the union of A and B. Of course, the union of A and B consists of the elements that are in A or in B or in both. So we'll pick the members of A and the members of B without the ones that are common. Well, we will pick the elements that are in here and the elements that are in here, avoiding repetition, and write it out as a set on its own. As you can see here, we have A, B, C, D, E, F, G. We'll pick one G because we have two G in the set A and B, so we'll pick only one. So the set A union B will consist of the set A union B will be such a way that it will be a measure set to A and B. What I mean by measure set is like A and B now become a subset of these two sets. Now let's check another one. So B. Let's look into B union C. In a similar way, B union C is going to be the combination of B here and C. We'll have A, if we arrange it in alphabetic order, A, C, since there is no B, D, E, F, and G. Yeah. And the next one, let's do the intersection of A and C. The intersection of A and C, we have by intersection we mean the elements that are both in A and C. Okay, and we can see clearly that A is in C and A is in A. C is in C and C is in A. So we have only A and C. Okay, yeah. So D, we will look into the intersection between B and D. Intersection between B and D, the elements common in B and D, we have F. F. What else? That's all. We have the singleton set F. Now E, let's look at A union B, difference C. Okay. Now we know already what A union B is. A union B is a set A, B, C, D, E, F, G. Difference C. C is the set A, C, F. So we are looking for the elements that are in A union B that are not in C. We see there is A here, so we cancel out A. We have a C here, we'll pull out C here, and then it's F here. So we'll be left with the set B, D, E, and G. So this is the result. F. Let's see the difference between A and B. Now we are looking at the elements that are in A, but not in B. We have A, B, C, G, difference D, E, F, G. The elements that are in so sorry for that. The elements that are in A, but they are not in B. And we see we have G here, so we cancel that out. So we have nothing else that is common. There's no element in A that is in B. So this will simply be the set A, B, C. Okay? A, B, C. Now, G, we have the complement of A. A complement is the universal set minus A. In other words, the elements that are in the universal set but are not in A. We have A is in the universal set, B is in the universal set, C is in the universal set, so these first three terms are out. G is in the universal set, so we'll be left with what? We're left with D, E, F, H, and K. Good. Let's look at something else. Let's see. A, the symmetric difference. A symmetric difference. B has a symmetric difference of A and B. Now, this literally is equivalent to A union B difference A. Okay. We did already the difference between A and B. We saw the difference between A and B to be A, B, C. Now let's work out first B difference A. As element B, we have D, E, F, G, A, B, C, G. Similarly, only G is common, so the result is going to be D, E, F alone. Thus, asymmetric difference B will be, we have A, B, C for A difference B, union D, E, F, which gives us what? The union of this, we have A, B, C, D, E, F. That is just it. Now the next one, I. Let's say asymmetric difference C. So similarly here we'll have the difference between A and C, union the difference between C and A. Now A difference B, difference C is we have set A, which is A, B, C, G, difference the set C, which is A, C, F. Now A goes out, C also, F is not here, so we are left with what the set BG as a result. And C's difference A, we have ACF minus ABCG. A is out, C is out, so we have the singleton set F. Okay, so asymmetric difference C is gonna be BG union F, which is the set BGF. Yeah. Now for the J, we have A intersection B difference C, and for A intersection C, I guess we've done that before. No, sorry, A intersection B. No, we have not done this before. So, well, the intersection we have the set A itself, which is A, B, C, G. Okay, intersection. The set C. The set B. The set B, which is D, E, F, G. Okay, difference the set C, which is A, C, F. Now this intersection, we see clearly that only G is common. Yeah, so we have a singleton set G, Okay, defines what? ACF, and of course this defines is equals the singleton set G, because there are no elements here that are here. So we need the elements that are here that are not here, and it's only G that is here and it's not here. So that is it. So this is the end for question 1. This is the end of question 1.